So again, hello everybody, and welcome to this open web meeting. As you can see here from the title of our web meeting, we will discover relevant partners in Agile Production and we'll get to know new business models to win the Industry 4.0 revolution. So let's have a look to the goal of the DIH² initiative. First, we can say that we aim at supporting the strength of Europe in robotics. And we can do that with a strong positioning of European players, not only large corporations, but as well SMEs. Here you can see three main points that we will address. The first one is in targeting the right application and vertical businesses and bring an added value with robotics. The second one is about targeting and using the best technologies to generate differentiation and competitive positioning. And the third one is in adapting the right business and revenue model. So, DIH² has received the support of the European Commission to support the SMEs to enter into Agile Production and to develop competitive advantages. We know that it requires specific resources, and this is why we are here today. The DIH² will also financially support you not only in finding the right partners, but funding you with up to 248K for collaboration among 2 to 3 partners, one of which I will explain you this later about the creation of the consortium that between end users and technology providers. This program will run for 10 months to develop technologies, the technology from TRL5 to TRL7, and will support 26 projects, 13 per call. Hello, everybody. I am Ermira Vodo, Open Innovation Project Manager at Blumorpho. I am here today with Ioan Boa, Innovation Developer at Blumorpho. Hello, Ioan.
Hello, everyone.
We are really pleased to welcome you to this open web meeting, and our speakers that we'll introduce in a few minutes will take the time to answer directly your question. Here you can see the open call process in a glance. The first stage of the open call was closed on October 31st. We are currently in the matchmaking process. It started the 1st of November, and on November 3rd was also launched the second stage of the open call, where you need to create consortia with 2 to 3 partners with a minimum 1 end user and 1 technology provider. Our goal today in this open web meeting is to support you to prepare the second stage of the DIH². Some of you have already applied in phase 1. Now you have to build your consortium to apply for phase 2 with the right partner addressing your technical needs.
So here is the agenda that we are going to see in a few seconds. So the first point will be about agile production and what are the possible business models. And the second point will be introduction of DIH² and potential partners for the collaboration. In particular, we will see Solian, Amiral Technologies, Little Sister, FNP Robotics, and Terracalis. And at the end, we will have a discussion about what to do next and a question and answer session. So the first we have to say hello to Joao. Hello, Joao.
Hello.
Hello, Joao. And after we are also with Amiral Technologies. Hello, Katia.
Hello, everyone.
Hello.
Hello.
Here is Little Sister, and we are with Stuart.
Hello, everybody.
Hello, Stuart. And from FNP Robotics, hello, Answedi. Okay, and to finish, we are with Terracalis. Hello, Thierry.
Why is Agile Production important and what are the current challenges? We will share with you a few challenges. As you can see here, there are 3 major challenges. We have discussed this in our previous open web meeting. So if you want the extended version, you can contact us later. Meanwhile, what are the current challenges Europe is facing in manufacturing? Just in a glance, these are 3. The first deals with the competition of China and emerging economies like Brazil. As you'll know, the issue we are facing in Europe is that we have higher labor costs and regulation, which at global scale, it puts us in a difficult situation when dealing with manufacturing. The second one, as you can see here, is increasing automation. In fact, lots of high volume production is done in Asia for cost reasons, and for a long time, globalization has been quite an added value. Now, things are changing as the opportunity to manufacture in Europe today is stronger. The reason behind it is because we see more and more automation, which can be very interesting for high volume production, but also for smaller batches. So in fact, for smaller batches, we need more adaptability. And as you will see, a solution has emerged to make it happen. And this, in fact, is an opportunity for Europe. The third challenge that you see here refers to the smarter customer base, which is very important, especially in Europe, as the final customers are really careful now and pay a lot of attention to how the goods they are buying are produced. This evolution, in fact, in the customer mindset is again an opportunity for production in Europe to produce closer to the customer with lower impact in the environment. We can consider that the closer to the customer, the less CO2 emission impact. Customers are more and more important to be taken into account, not only to sell, but also to produce. And this is a new opportunity for you to assess new ways and new solutions to address your market. And here, in a glance, as you can see, the world is changing fast, not only in Europe, but as well in Asia. Emerging technologies like artificial intelligence is bringing a real disruption globally. Everybody is speaking, as you know, about artificial intelligence, and AI brings a lot of different opportunities. This is, as you can see here, true for China, for North America, but also for Europe. Access to technology has to be considered as an opportunity for all organizations, and this is what DIH² is focusing on. I will introduce you in a glance the new business models. I see already that we have different questions. Okay, thank you very much. And in fact, I invite you to continue asking your questions, and our speakers will answer later in the Q&A session. So to focus on the business model. What is a business model? The difference can be illustrated between the business and the revenue models by the individual components of a business model. But first of all, let's have a look to the definitions that you can see here. A business model describes the way a company generates, delivers, and captures value for itself as well for its customers. The revenue model that very often is used in the everyday life as a synonym of the business model is in fact a subset component. It describes the structure of how the company generates revenue, and each customer segment can contain one or more streams. So the difference can be illustrated by the different components of the business model, like the first one, who are the target customers? The second, what is the benefit that the company provides to its customers? The third, how does the company deliver this benefit? And the fourth, how does the company earn money? And this part of the component is the revenue model. Really, in a glance, you can see a few revenue models here. The first one describes anything as a service, describing, in fact, a broad category of services. Here you have a few examples, and of course, there are many others. Today, to consumers, the as-a-service model becomes synonym of anywhere, real-time, personalized service with ongoing value and on-demand fulfillment. To the service providers, it means enhanced efficiency and profitability. And regarding the smart factory as a service, this is a combination between competencies such as software integration, automation technology, systems engineering, and risk and financial management. And the way it works is by negotiating the KPIs in advance of the equipment. And there is no purchase of the machine, but instead is the purchase of the subscription, hence machine as a service. We have talked about the business and revenue models in our previous open web meetings, so feel free to ask me the extended version after this web meeting. Now, this is one of our favorite definitions about agile production. To be agile is to have the capability to survive and prosper in conditions of unpredictable change by reacting quickly and effectively to changing markets. So one of the keys also to survive is to benefit from the best ecosystems. Thus, we are glad to introduce you our speakers that are part of the DIH² ecosystem that we encourage you to join to. The first one is Solien. Joao, I am giving you the floor.
Hello, everybody. So first, I'd like to thank Blue Morpho for this invitation. My presentation purpose is to provide all DIH² network partners information about CIRMAF and our skills in robotics. CIRMAF has 30 years of expertise. We are specialized on the design, construction, and commission of these product families, focusing on robo-cells. These images show our solutions, their design and construction. And on the next slides, I will show you some examples of CIRMAF robot cells. So in this case, this robo cell was developed to assemble, bolt and lubricate customer product. We have many robot interfaces for loading and unloading stations, different stations for different product families. We have automatic feeding of some parts. We integrated 3 FANUC robots. The robot brand is normally a customer specification to which we adapt, and we integrated all the programming for the 3 workers to work together. We developed the grippers to have quick changeover for different customer product families. On the next slide, we have an example for the bicycle industry. Here we developed it to assemble in this station, to assemble some components, to machine the parts, and to do some lubrication of the component in the end. The gripper was developed to have a quick changeover for different custom product families, and we also have interface between man and robot for loading and unloading stations. Okay, so in this example, we have a robo cell that we developed. You can see here the image of the design to do the assembly, bolting operation for the 5 wheels of a car, so the 4 wheels plus the safety wheel. This was a big innovation project and a big challenge. We have a huge variety of wheels. We have imprecise feeding of the wheels and of the car, and the imprecise positioning of the car wheel hubs, so that we can assemble with the robot in automatic all the wheels. So in this case, we developed a system where we integrated 3D vision to scan the wheels and to scan the wheel hubs, and we automatically program the robot trajectories so that the robot can match the bolts on the wheels and the wheels on the car hubs. The solution was based on 2 ABB robots, and we integrated the cameras and the nut runners on the robo gripper. On the next slide, you can see, machine directive compliance is mandatory in CIRMAF quality management system. RoboCell machine directive norms and safety solutions for RoboCells are evolving. These past years, we would like to highlight the transition that we followed, and we used and we see as some good improvement from hardware safety solutions to safety by software using safety PLCs and softwares like SafeMove, or in this case for ABB. So these being examples of what we do at the moment, I'd like to also share with you our vision for the future in our next slide. So aligned with Industry 4.0 main guidelines, our vision for CIRMAF production systems 4.0 is based on the integration of machines, robots, vision system and AGVs with a modular concept for safe, flexible and connected solutions, reducing customization to product, machine and MES interfaces and specific customer requirements. Also, with this, opening new opportunities to change to a new revenue model like machine as a service, is something that we are quite interested. So with this said, I'd just like to inform you of my contacts. Please contact me if you need any further information, and thank you.
Thank you very much, João. This was very interesting. And now is the moment to give the floor to our next speaker, that is Amiral Technologies. Hello, Katia.
Hello, everyone. Hi, Mira. My name is Katia Hilal. I'm founder and COO of Agile Technologies. And I'm here to present to you our solution based on a predictive analytics technology for blind failure prediction. Okay, so we come from public research. We bring to the market an innovative technology allowing industrials to predict failures and to enhance their production quality based on a mix of automation and artificial intelligence principles. Okay, so the aim for us is to solve the problem of industrials, which is downtime either of production or downtime of an equipment. Today, we have lean manufacturing, we have very short timescales for production, and also the business models are shifting from selling equipment to selling hours of availability of the equipment. So any hour or any minute of downtime leads to a lot of loss in revenue for the industrials. Predictive analytics and in particular predictive maintenance or failure prediction reduces the maintenance cost up to 40% and reduces downtime by 50%. In addition, our aim is to extend the lifetime of equipment, and this of course has environmental impact. The challenges when we talk about predictive analytics or predictive failure detection, when we are talking about an industrial environment, is that you have multitudes of equipments, and each equipment is in itself composed of many subsystems and sub-equipments. So that makes a whole lot of equipments to deal with, and a whole lot of data that you can collect from these equipments. You can collect vibration, you can collect temperature, humidity, pressure, electric signals, all kind of data that you can collect. So you are today facing an overwhelming quantity of data to deal with, to do any prediction. That's one of the first challenges that faces artificial intelligence into the industrial environment. And the second challenge, you can see down in the slide, is that if you want to apply artificial intelligence, you need some data to learn from, right? So if I take the example of Google recognizing a picture of a dog, Google has learned over millions of pictures of dogs to be able to recognize any dog on a picture. When we are in the industrial environment, we don't have millions of occurrences of failures to learn from. And sometimes we don't have any data at all, even of non-failure data. So that's the other challenge to deal with. And this is why we are here actually with a solution that we call blind failure detection. So without the need of historical data of failure. So here's the principle of our solution. You have your sensors generating data. These data can be in the format of a time series, which means data that evolves over time, coming from different sensors. And you can have also some contextual data or process data coming from other types of data collection. Our technology enables automatic generation of key indicators, key health indicators coming from these time-based signals. And when we have generated these key indicators, we are able to build a vision of a space where our health indicators evolve while we are in a normal situation. So we are able to learn on a machine that is in a good state of health and build our normality space, and from there detect any deviation from normality and characterize this deviation. Are we deviating because we are facing a defect? Is it aging? Or are we completely nearing an end of life of a device and we have to replace it immediately before it fails? So this method, as you see, does not require historical data of failures. If we have historical data of failures, that's even better, because we will be able to add this information to the algorithm and even characterize our deviation even more. In addition, we will combine our analytics with the contextual data and to build sort of a signature of every type of defect that we encounter. And as we generate many health indicators, we are able to very precisely define our normality space, define our deviations, and characterize the type of failures that we are encountering and predict these failures before they happen. So this is the principle. I'm going back one. So what is our value proposition here? Here we are able to deal with complex problems with multiple types of data coming from different equipment. No matter the type of data, as I said, electrical data, vibration, speed, etc., we are able to automatically extract our health indicators. The second value proposition is our agility and speed. We are very quick to find the solution to a specific problem because our process of generating the key indicators is automatic, and hence our generation of the prediction model is also automatic. The model that we generate is easily integrated in our customers' processes and platforms. It can run on our cloud, on the customer cloud, or on premise. And also the interface that we supply does not require on any coding. So domain experts and operational staff can use it very easily. Unsupervised learning, meaning learning without historical data of failures, is very powerful to our solution, and we have proven performance on different use cases where our rate of prediction of the failures was higher than 96%, even will go up to 100% prediction, depending on the use case, and with a low level of false alerts. Our technology can be applied in multiple cases. Of course, as I've been saying, failure prediction, but also non-destructive testing. For example, testing of infrastructure and testing of parts of equipment using some non-destructive methods. We also apply our technology to produce prescriptive maintenance. So what is prescriptive maintenance? Today you have three types of maintenance that are known. The first one is curative maintenance, or after the failure maintenance. Second one is preventative maintenance, where you replace pieces on a regular basis. So this is a costly method actually of avoiding some failures. Third one is predictive maintenance, where we predict the failure before it happens. And the fourth one, the prescriptive maintenance, is where we tell you what type of maintenance to do now to keep your production at the highest level of quality. And so we are able, provided we have some data, to tell you now you need to do maintenance operation number 1 or number 2 or number 3 to keep your production quality at the highest level. And the third use case is quality diagnosis for manufacturing. So at the end of the manufacturing process, your equipment goes through testing, And from this test, we will be able to automatically define or designate the equipment that definitely should not be shipped to the customer, but should be fixed for this failure or that failure. We operate today in different industries, mostly transport, as you can see, but also in the energy and manufacturing industries. This shows you a few of the rewards that we have been awarded, and the last one of which we're very proud, the iLab reward that gives the that is specifically designed for deep tech companies in France coming from public research. You have my details here, and I will be happy to answer any of your questions.
Thank you very much, Katja. This was very interesting. So our next speaker is the Stuart from Little Sister. Hello, Stuart.
Hello, can you hear me?
Yes, we can hear you.
Great.
The floor is yours.
Thank you very much. Thanks to the team and for the organisers for help and advice. So I'd like to introduce how we can accelerate factory automation with our product, which is called Little Sister. And Little Sister is basically a very secure social network for machines and people. It has a built-in IoT gateway, so you can assign access, control, send information very securely to advanced production environments, partners, and so on. So basically, how do we use Little Sister? We install it on PCs to secure critical infrastructure, and we replace email and insecure internet. We use a parallel internet standard, which is used by NATO and Cisco. What we do for the first time is IEEE harmonization. So we're able to have a standards-based way to integrate information from different sensors and protocols. So that makes automation easier and easier to put together different products. We use, as I said, trust-based connections based on XMPP, and that is peer-to-peer, and it's also low latency, and we have end-to-end encryption for privacy by design and easier compliance. It's GDPR compliant out of the box because your information is always encrypted. And it works as a private social network, so you can assign access and data flows for your industrial network, your teams, and your partners. So what we're doing is bringing a social network functionality to collaboration for machines and people in industry. So our offer is we're software as a service. It's based, as I said, on standards. You install this currently on PCs, and the human interface is a standard HTML5 browser, which you can customize. And we have an encrypted database installed on each peer, so that the information is stored encrypted and it never leaves your machine unless you choose a trusted connection to receive your information. So you control the information at the peer, so it's very secure. We use an IoT gateway built in, so you can talk to different types of machines, different protocols, whatever you require. We can have auto or manual backup, and we have an API, so if you want to run other applications, you can do this. For example, you might want to run AI type applications, so we secure all the information, and we can even have metadata, auto or manual, and there's scripting as well for interfaces. So we're basically a platform that you can add, a secure platform that you can add applications. The application we've added to start off with is a social network for machines and people. Okay, it's also a resilient architecture because it's federated. So for example, this could be three regions, 3 factories that want to collaborate, and the information is held on each factory. You can include information flows to other factories securely, but with end-to-end encryption, and each if you like, factory would have, in this example, a broker and 4 peers. It can be more peers. This is just for the example. And this is all built on peer-to-peer communication, which is much lower latency and also lower energy, because you're not sending a lot of data that you don't need. You're just sending it only to the peers that are in your social network. So this is a quick overview of our technology stack, just to show that it does exist. And so you basically, the product is a browser UI. It's a white label product, which means you can have your own fonts and custom look and feel for your company. It's multilingual because it uses a standard HTML browser. And we have the IoT gateway and a database built in. And that runs on the IoT harmonization layer from IEEE. So it's built in for standards. It's built to incorporate other products, so to help you rapidly prototype new environments and collaborate for advanced industry. And this runs, as I said, on XMPP, which is a standard internet protocol stack that's been out for over 10 years. Right, thank you very much. I'm happy to take any questions and give you more information. This was a very quick overview. Thanks again from me here in Stockholm, Lillsis AB, and our product Little Sister. Thank you.
Thank you very much, Stuart. And we are giving the floor now to Hans Rudi and F&P Robotics.
I'm very glad to introduce F&P's approach to optimize and help in a highly flexible, personal way. So we can see the robot here on the slides, which works together with humans, and that means robotics is connecting to humans more and more. So the challenges are big, because industry needs automation everywhere, not only in the traditional parts, which they were, but now it comes to fields, to small companies, a little bit special applications. This is more and more the topic. And here you cannot always have a very expensive solution, but you have to have individualized applications which may change shortly again, and so it is too much to always have a big project. Second, the individual needs are coming more and more. Everybody wants to be served very individually. Also, that calls for high flexibility. And last but not least, people want to interact more and more, and we have to interact with the fields of applications which we talk about. And then you can choose to have a very expensive solution with an ability of touching humans with all the safety measures you can imagine. And normally the costs of such a project are double as much as a normal robotic project. And our approach, you can see in the next slide, goes in the different direction, that we try to use a personalized robot, which is soft covered, which is very adaptive to persons. It can understand voices, it can recognize faces, it can touch people in a safe manner without any fences. And this approach is an option for applications which do not need all the demands of a high price solution, but just do it the easy way. So we have that for industry, collaborative robotics, but we have specialized applications also on service robotics fields like care robotics with the Leo robot, and then also in gastronomy, where our robots are used also to prepare drinks, serve drinks, and other work to do in gastronomy. Today we talk a little bit more about industrial applications, but it is very close to the service applications nowadays, and therefore I think there is a big overlap. In the next slide, you can see what are the demands and the application possibilities we can serve. So in industry, it's about safety, but often, of course, also about speed and forces. And here we have to say, if it's highest speed and big forces, our FMP robots are probably not the right solution. But often you have to wait for processes, or it is food which is not able to be moved extremely fast, or many other reasons. There are tons of applications which is enough to have a cycle time of 3 seconds or more. And then you can do it with a personal robot solution. In the care sector, it needs a lot of intelligence to be aware of the situation, where the people are, to understand what they want, because it's not always the same. It's very depending on what is the today's feeling and need. And in the gastronomy, we have to provide not only work, but also a lot of fun and entertainment. And also there we have algorithms who support that. And now the nice thing is, this all can come back to also industrial applications. We have all this intelligence and sensorics available for all kinds of tasks. In the next slide, the robot is described more in detail. This is the P-Rob, which is the central technology for all the applications we have seen. It has an interactive ring on the top where you can just press and it reacts to you, whether it's to open, close the gripper, whether to go to a certain position, or you have something programmed specifically. It can fast calibrate because it has absolute sensors and is very at each point where it is, it can do that. It connects to all kind of platforms, TCP/IP sockets or Wi-Fi and so on. We have easy exchange of tools. With one screw, you can exchange the gripper. Intrinsically safe. We have 2 versions. The 24-volt version is very easy to have installed because it does not need any fence and not risk analysis. So thanks for your attention. I hope you have something in mind which our P-Rob Leo solutions could serve.
Thank you very much, Hans-Rudi. It's really interesting, the different applications and the technology. And we pass to our next speaker, Terakalis. Hello, hello, Thierry.
Hello to everybody. Hello to everybody. I'm glad to have the opportunity to present how our company, Terakalis, could contribute to support the agile production. First, I would like to tell that we are focused on material and manufacturing process relative to materials. Especially, we are dealing with what we call technical materials that which ensure some critical function, such as structural withstand, thermal protection, electrical insulation, and you can find all these materials in different sectors like automotive, aeronautics, semiconductor, and so on. The characteristic of this material that their performances rely more on their inner properties than surface properties. This material bear very high responsibilities, and there are a lot of pressure, contractual pressure for the manufacturer, and also insurance pressure you can have. And fourth idea that today there is a very high trend in innovation in such a domain, and in the materials, in technical materials, where we are very strong development today in terms of composite material, assembled material, and multi-layered material. Next slide, please. So knowing the context of our focus, our field, which is a technical materials and the manufacturing process, the situation today that the processes to transform or to assemble such material today, the processes are not well understood and even not well controlled. And this is a key negative point in order to allow fast adaptation to market demand or to changing environment. So this is like an obstacle, a hurdle today to deploy agile production in the field of this industry to manufacture technical materials. And the main reason of it is that today there's a lack of flexible devices that are able to analyze the inner properties of material on a real industrial parts. That means real industrial parts are many times 3D, are thick and a large size. And also the real industrial part are the parts which are producing, not the part from extracted or building or manufacturing for lab use. So we are talking about the real industrial part which are produced, which are producing on a production line. And also another point that if you want to better understand your part, you need a large scale of data about what you produce, and this is a lack also today. And if you want to do it, you need to, what I mentioned, that to do it on the fly. That means not to do in the labs, but better to do directly on production line, and this requires high-speed analysis. And these devices today are very limited to, I would say, one technology today, which is X-ray technology, which is able to do such analysis online on a real industrial part. But this technology today, X-ray technology, is quite limited for many reasons, and that is why today we are industrial manufacturer today faced at the fact that there's no real flexible device today to ensure and to improve a better understanding and better control of what they produce in terms of technical material. The solution I would like to propose, it's a robotized inner inspection of polymer, elastomer, and ceramic parts, which is the scope of material where our technology could play a role. And also for this material, including what I call advanced processing today, because when we are talking about advanced processing, like composites or even package materials or multi-layer material, this advanced processing create also some difficulty for the analysis. And the technology we developed today is adapted to the new complexity induced by such advanced processing. For instance, I give an example. If we are talking about composite material, it creates anisotropy issue that you need to face with your technology in order to be able to detect defect or to analyze and control inner properties inside the material. And we have developed such a solution able to deal with anisotropy of the material. So the solution is based on the association of robot and what we call terahertz vision. It's a new range of electromagnetic waves today, which allow to reach the performances and the assets that we display in this slide. That means non-destructive technology, high capacity of penetration. I'm talking about few centimeters inside material, fast and accurate imaging, and thickness measurements. So I display the performances that we can reach. So for imaging, it's a defect less than 1 millimeter at a rate of 1 meter per second in terms of control. And for thickness measurements, we are starting from 5 microns thickness until to 10 centimeter thickness that we can measure at a high rate of 200 points per second. This technology is contactless, easy to integrate, and no risk for the user. It's a non-ionizing technology. And here at the right side of the slide, you can see the type of defect or properties that we can measure and control inside a material as example. So donc to make a synthesis of what we can bring in terms of value, we have selected 2 use cases. The first one, that this technology could help you to get more knowledge about your manufacturing process through some learning campaign based on inner properties data acquisition. That means many times we face some industrial customer which are not able to describe what are the inner defects that they could have in their material, where they are localized. Even they inform us that okay, the models that they use to simulate the transformation of the material is not enough effective today for them to have a better understanding. And the first part, that they have difficulty to know the real impact about process parameter variation when generating defect or bad properties. So what we offer is really to learn manufacturing process through learning campaign and gathering data, and also through AI, donc artificial intelligence, okay, to analyze this data and to provide a customer relevant information about his materials, about his manufacturing process. And it helps, the better understanding help, of course, to accelerate the market, the material market adaptation. The second part where we can help is really in terms of control, to provide adaptive and fast inner quality control of 100% of the products, and many times the products are with 3D geometry. And this could be performed thanks to first Terrace Vision, which help us to do donc 3D sensitive fast insight into materials, and robot also, which help us to have to get augmented accuracy, higher sensitivity, and flexible, of course, inspection, able to adapt any change of product based on CAD information in order to adapt every time for instance, the trajectory of inspection according to the 3D dimension and the 3D geometry of a product. So it will help us, it will help you to ensure the quality of your technical materials. And even we talk first about the learning, but you can gather all this information, you can trace all the inner properties about your product, and to make it as a base, a database. And this database could be used maybe later, I mean, when the product is in operation, to be able, after failure, to understand what was the parameters, the inner parameters of your product when you produced it, and in order to better understand the correlation between inner properties and potential failure, which can occur later on. So just as a conclusion, that we think that increasing the knowledge of manufacturing processes through inner quantitative measurement and through data analysis, also through developing adaptive and faster inner quality control of 100% of the product on the industrial production line, we think that it could contribute to accelerate and support the agile production of our technical materials. Okay, I thank you for your attention, and I'm available for any question or any contact further. You have my detail on this slide, and I will be happy to answer your question.
Thank you very much, Thierry. And Thierry from Terracalis was the last of our speakers. What to do next? We will send you the presentation so you can have all the details, but here you can find our guide for applicants and the link. Regarding the brokerage events, you can find your DIH² country representative, and you can write directly to the email, to the help desk email, if you have any question or if you have any doubt. Other useful links, as you know, the open call is ongoing. Now we are in the second stage with the deadline 27 February. So please do not hesitate to ask any questions if you have any doubt. Now you are in the matchmaking process. And for the ones that have already found the partner, you are very welcome to submit your application. So at the end, here you have my contact details. Do not hesitate to write me or call me, and I will be very glad to call you, to contact you, and to explain you your doubts. So now we are in the Q&A session. We have received different questions, and I leave the floor to my colleague Johan.
Yes, perfect. About the different questions that we get, we will start with Solian. So the first question is for you and coming from Eric. And the question is following: what is the role and importance of data management in your integration, connectivity, and robotized process automation? Do you plan to use digital twins to enhance the performance of your solution?
Hello, thank you for your question. Well, the data management of our solution is a very important point. All the connectivity and interface between the different systems and between the different users of the equipment is more and more relevant to the fast adaptation of the system to the continuous and fast changing of the environment. That's something that we are working on in the moment, in terms of all the traceability of the process, all the sensorization of the equipment, and the communication with the HMI of the equipment and with the MES systems. And in the future, the increase of automation of artificial intelligence in this field has huge potentials that are something that we are willing to explore.
Okay, perfect. Thank you for your answer, and of course we will share your presentation and your contact, and if needed you can continue the discussion on this topic.
Okay, of course.
And the next question that I have is for Amiral Technologies, so for Katia. The question is the following: which infrastructure or technology are you using to acquire, integrate, and infer knowledge from heterogeneous data?
Yes, so we have our software solution that can run either in our cloud or in third-party platforms. It can be on the customer's private cloud or on the customer's premise, or on the customer's third-party platform if necessary. So we have APIs to collect the data from multiple sources. We are agnostic to the data type, and we do not deploy sensors. So we rely on the integration with the different data acquisition system of our customers, coming to the infrastructure or to the platform, and then to feed into our predictive analytics system. We support, of course, file transfer, but also real-time acquisition of the data, and we adapt to the protocols that the customer uses. There are some standard protocols, but most of the time the customers have their own protocol that they work with, and we can adapt to them.
And the same for as Solian. Of course, you can continue the discussion if the answer is not enough with the person. The next question is for F&P robotics. So the question is following: how easy can the F&P robotics products be implemented into the environment with other devices?
So it is indeed easy for several reasons. First of all, as explained, we have not high security devices to overcome. You just can put it next to the other environment just physically. Second, we have a lot of input possibilities, including voice. That means it's even possible that persons talk to our system, and this is the connection. Or they touch a sensor, and then that's also an input. We have also IOs in the base, which can be connected easily. In addition to that, we have all kind of protocol support, TCP IP sockets. We have a special easy add-on so that any connection to another program is possible just through this socket, which you can install on the web browser and directly communicate with our F&P robots. So there are really a lot of possibilities we implement to make it as easy as possible.
Thank you for your answer. And the last question, my question is as following: how the manufacturing company can know if TerraCalid solution is compatible with their defect solution, with their defect detection. So my question is, yes, to understand, have better understanding about TerraCalid solution integration in manufacturing environment.
For this, we own our platform in Montpellier, where customer could bring some industrial parts or some samples sometime, depending the size, and we can make some preliminary test or feasibility study in order to demonstrate first that we can detect some defect, or we can measure some properties, inner properties and inner defect. And then we can do more about repeatability or reproducibility test in order to give idea of level of performance before, of course, before buying or installing materials. Every time we have some demonstration phase, we can organize on technological TerraEarth platform.
Good understanding. So it will be the way to have a good idea about the way to use TerraCalid solution and how to implement inside the manufacturing. Okay, understood.
Yeah, by the way, the test could be done on a platform or directly on customer site. That means we can think about doing a test directly on the production line if very sense to do it.
Okay, perfect. That was my last question, and sorry we are a little bit late. So much interesting things to share today. So that's can explain how we are late. Okay, thank you.
Thank you very much, Johan. Thank you very much to our speakers and to our audience. Please do not hesitate to ask any question for our speakers today, and it will be our pleasure to put you in contact and to answer your questions.